Hello, ci video hi collision evolve hintin. Collision zong hi na system of particles part a hintin na. Chu le collision bana zong hi rotational motion zong ko NCERT textbook kan velo chun system of particles chapter ma cho. So let's see. Collision a hema sapena he diu chuna. So there is something called coefficient of restitution. Chu pi ham. Formula he velo chuna definition tata khazong chu umnan dine jong le ehoni man penu hena so exam la dunga ki dong pa he piam tele ce is so the coefficient of restitution is given by the velocity of separation divided by velocity of approach. Separation chu vedang example chala he velo chun ball nium chana ela bodies nium cho mass nium na so you have two masses, suppose they are moving towards the right. Okay, u1 chu mass 1 per initial velocity na u2 chu mass 2 per initial velocity cho ale to he given condition na if u1 is greater than u2 anunga pa he na aha cho ale chun batang chong pha phala chun anunga pa he na maya pa chu an hongki collide chula na so they will collide one another. So let's say after collision now you have this situation mass masapa chu velocity chu v1 na mass nukha pa chu velocity chu v2 ale collision zo he na let's say v2 is greater than v1. Okay, chala hi velocity of separation cho piham dele collision zo na collision zo so relative velocity pa cho chu piham dele v2 minus v1 na chu velocity of separation is a velocity of approach cho piham dele so same thing u1 minus u2 e hi alhang pi hi e pa hi positive value cho che pa hi negative hi lo na che chu chila hi alin zo pa ko na cho ne zo pa so subtract na bol di hojing. Okay, maybe v1 minus v2 jong thai v2 minus v1 jong thai na value pa so negative hi lo so na minus na bol di o che pen so same thing on the initial side also, right? u1 li zo hi sa chu u1 minus u2 na formula cho so here you have v2 minus v1 divided by u1 minus u2 chu coefficient of restitution ki ti cho je ale hin chila hena suppose collision hi collision pela hena suppose there is energy loss, okay, during collision. In reality ata chena so whenever you have two collisions so energy is always lost. Okay, energy loss hungu mal chon ptm tele aki kolai zo hena aki kolai zo velocity relative pa hi velocity hi chpa hi initial asangai hlomzo de ta cho energy loss omje acho na kinetic energy loss omje acho so final kinetic energy pa chu initial asanga hi hlomzo ta cho chala hi. In this case you have so the velocity of separation now becomes lesser than the velocity of approach. Final velocity chu na initial velocity sanga chu hlomzo ta cho chala hi. So in this case what will be the value of e will be less than 1. Okay, second case achu if no energy gets lost in the collision, suppose let's imagine collision as energy has lost loads na so loss low imagine valuation so here you'll have the velocity of separation after will be equals to velocity of approach before. Okay, see in this case numerator to denominator ke balachun value chu piha 1 hong ni chula la he so here in this case e is equals to 1. Okay, chiti lawa jong chu so here collision zo hena ki collide zo hi if the bodies stick together he all inelastic collision in sim diu na je phalachun he pen hi in je pen evela in sake diu cho chala hi lang pia honi ve chu e value pai holai para holai chan omam ti he na dinga chona chi case thumi kan sim cho chala hi bodies if the bodies stick together they will move with the same velocity. Collision aki kolai la cho aki kolai zo cho aki chi dan hona la chun na aki ma dan hona chun chi kho mun ta chola na chala cho a chi kho hona la chun v2 minus v1 to 0 ta cho haji cho velocity hon ke ba ja chuna so in this case e becomes 0 aji cho numerator pa he 0 ta chala he. Okay, alang pia chu e chu you will have e equals to 1. Okay, e equals to 0 and e in between 1 and 0 he chi case thomi cho chala he ajo phala types of collision asuna he se pani inside cho. Okay, coefficient of restitution to piham velocity of separation divided by velocity of approach. Okay, next let's see one example here. The example I have I have two mass. Okay, so they are moving with 5 meter per second and 2 meter per second initially before collision. Okay, mass to 2 kg to 1 kg na chala hi ale ko aki kolai jawa chu mass to 2 kg to 1 kg ta 1 kg pa chu a velocity chu peta so 1 meter per second to 2 meter per second ke pi chu chi question na al question chu pm e chu pm what is the coefficient of velocity restitution na formula chu pitam formula chu E equals to velocity of separation divided by approach na chila hi separation hi zat ham 1 to 2 ga diu te chepen hi m1 diu ten chepen hi let's say this is u1 u2 so v1 v2 na formula sa mala chun E chu v2 minus v1 divided by u1 minus u2 it is na so here what will you have v2 to 2 minus 1 divided by u1 to 5 minus 2. Okay, so how much will you have? 1 divided by 3. So E value is 1 by 3 na. So here we can see that E lies between 1 and 0. Okay, it's equation na na. Okay, abana question khato bolbe to E topic ahe. So a ball falls on the ground from a height 10 meter and rebounds to a height of 5 meter. So calculate the coefficient of restitution. Ita hichi case ha suppose ball khanum chona chala hi hichi ball pa hi falls atila chun chala ki release cho chi. So ball is released from certain height na chi height pa chu 10 meter ki pi chu chala hi ale ball cho ki release ala chun tool chu ri chula na tool chu ding ten tool to ki collide cho ki collide ding ten bana chu ki nung chun ki de na la hi ale tool athuna hi na tool athuna hi velocity is at them. So what will be the value of v? So root over 2gh. Formula here na energy conservation ako na cho initial cho mgh cho mgh ma. So finally you have half mv squared. So from here so you'll have v squared equals to 2gh na. So this is v root 2gh. Okay, value po leo chun sa hang pot di ham. So 2 into 10 into height to 10 ki pina chala hi. So this is how much? 10 root 2 meter per second. Hichi just before collision. So just before collision hi value chun batang collision chu ipile pm ha ball to ground chula na chi. So ground is at rest. Okay, so ground pa 2 tiutin ball pa 1 tileu hen u1 chu pi ha before collision aso 10 root 2 na chi. u2 chu pi ham 0 ground chu rest am chula na chila hi ale ahung ki collide a chula ki collide jo chu ki rebound ki chula na ki rebound ki ra hoila chan lungam. So it rebounds to a height of 5 meter adi cho chila hi. So therefore after collision the ball now goes up again with some velocity, final velocity na chi hoila chan lungam chi pa hi 5 meters and lung kit na chila hi batang galeng to to ding in highest point of ding highest point achu v0 ki su ta chala cho. Okay, now if you know the height v hi pi ha v is at ding ham. So same formula root over 2gh. Okay, so 2 into 10 into height to 5 meter. So this is what 10 root na chi hi. So this is 10 meter per second. Root 10 square na ale chala hi final velocity chu after collision aso na chipen hi v1 hin ta chu v2 chu pi ham v2 chu again 0 ground chu rest am dan lai chula na a ball pa po se chu kenung chun hi za. So now we have all the velocities we want. u1 ma u2 ma v2 ma v1 ta na ale e chu za ding ham. So e is equals to v2 minus v1 divided by u1 minus u2 na formula chu value put leo chun v2 chu 0 minus v1 chu is that ha 10 na divided by u1 chu is that ham u1 chu minus 10 root 2 ibola minus 10 root 2 ha nui langa chi so ja na chi velocity cho je pen direction cho. So this one it is going downward, so minus 10 root 2 minus 0 ground chu resa na. So here if you solve, how much will you have? Minus 10 divided by minus 10 root 2. So this is how much? Minus 10 minus 10. So I will have here 1 by root 2. Okay, e value chu 1 by root 2 na chala jong e hi pi ham. So it lies between 0 and 1 na. Okay, abana chu types of collision ibol da so sim. To e hi pi ke nam he do tai jana. E is coefficient of restitution. So v2 minus v1 by velocity of separation divided by velocity of approach na. To hi collision hi type hi thuma ke hom khen chu masa pen chu perfectly elastic ke tin den na. Happen chu perfectly inelastic ke tin den. So in the middle you have partially elastic or partially inelastic. Okay, hichi chubata e value akuna cho e value 1 itiu chuna chehem. So e equals to 1 chu piham dele. So that is the case of perfectly elastic. Okay, where energy is no lost. No loss of energy, no loss of kinetic energy na chila he. Hichi hi piha, so some energy is lost. Okay, and here piha chepen here. So here large energy is lost chu zo phala deformation to azong sei di na. So based on deformation, here you have complete deformation, bodies stick together perfectly inelastic ki di chu abailam ta he dinga chu na. After collision, so bodies stick together depends completely inelastic din chu e value chu 0 na. Abala types of collision chu thum ti lawa jong chu na, batang head on collision to oblique collision ki ti khajong ve da chi. Head on collision chu biham tele chalaya hi example feda ball ni chela hong chu na. Line of motion ki ti chu piha ball chi na line pa chu na. So this ball blue pa hebela chon hi tai hong chu na chalai line a hi chipen hi line of motion na chipen hi khat pa jong black pa jong chu hi tai hong tin chipen hi line of motion. Abana chu ahongi kolai ra chu na, ahongi kolai ra chu center ten hi join leo chun is a line khat hong ve da chipen hi biham de line of impact. Okay, head on collision a khoi ptm dile is a line of motion pa to hin na, line of impact pa hi, so they are equal. Okay, chu head on collision na. Oblique collision chu biham dile, so here blue pa hi velo chun hi pa hi blue pa line of motion chu chi na. Black pa chu ahonga chu line of motion chu pa hi black pa line of motion. A hi wanga chu ki kolai ra chu center ten in zone chun line of impact pa hi chelangam chu. So now you see they are different, right? Line of motion to line of impact pa chu ki banglo so chi. So this is the case of oblique collision. Okay, right? So here to a collision type to me say ho chola na he cho chu ga value hen. Suppose mass nium cho nya jete ni, so they come towards each other, so there is collision. Okay, after collision, so here in the first case ma sa pena deformation im cham lo cho. So body cho shape chu na angai nge shape a chu nung chi ki cho after collision, so the body completely regains its shape. Okay, so here there is no deformation here. Okay, he che pa he a case ta che. So this is the case of what? Perfectly elastic. Okay, so there is no deformation here, perfectly elastic. Abalan chela e chu pita e is equals to 1. Right? And next chila a second case I will chun chi hi two balls approach each other na, two masses approach each other, collision so na. Let's say some part is already gone. Okay, them khat bal ha ta chu. Okay, maybe it gets deformed. Okay, so here deformation ki to shape chu ki hial tin cho chela he a shape chu ki he them khat ki hial na chela hi collision so wa cho. So here some deformation takes place. It's a pen hi biham tela, this is the case of partially elastic. Okay, a hi lo le partially inelastic na chi hi chi case a hi hi pita. So e lies between 1 and 0. Okay, chi pen hi na ale athum na pen hi. So here if you see after collision, the bodies now stick together. Okay, in this case bodies masses stick together. Okay, so here you have complete deformation. Depends on this is the case of perfectly inelastic na chi. So perfectly inelastic hichela e value is at ham. So here in this case e is equals to 0. Okay, so these are basically the type of the three types of collision na. Collision ki hop khen na za thum cho chi. Next case a chu tang lecture ma sa chu conservation of linear momentum I bol chana chi. Ale he chi case thum hola hai na, which is linear momentum ki conserve them. So if you look at everything is see lang pia collision lai ta hi external force ma cham no pe chula na chela hi. So therefore in all the three cases you'll have conservation of momentum. Okay, linear momentum is conserved in all the three cases. Okay, first thing. Second thing, so we have the conservation of energy. Total energy is only conserved. So three cases I have. Conservation of energy bolo chala na, work power energy chapter acho. Initial energy equals to final energy. So KE initial plus PE initial equals to KE final plus PE final bolo hocho. So this is valid here, okay, in all of the three cases. Ale athum na kinetic energy pa hi athumai aki conserve them. So here kinetic energy batang he deformation hi pite na ha. So deformation chu di phalom ding ham tele energy loss ahum phala chun na deformation omle chu chala. So deformation o mala chun. So in the second case and the third cases you see, so there is deformation. Okay, is it bolam ham tele energy lost om ja so na chala he. So energy loss ke di kinetic energy loss om ja so na chala he. So here kinetic energy loss lo na pa cho helai ha, perfectly elastic collision so kinetic energy loss lo so chala cho. So in that case only kinetic energy is conserved. Okay, remember kinetic energy so perfectly elastic collision ajo kinetic energy pa chu ki conserve so chala he. Okay, so in all the three cases, momentum is conserved. Masapena chu total energy is conserved na. Abale perfectly elastic collision condition achu chila chu kinetic energy conserved. Right, so there is the three types of collision. Okay, now collision formula na. Question solve na ding as a formula khang ngai chula na collision. Final velocity so chu watang alang pia chu initial velocity so kipi so. Mass m1 to m2 chu initially, so they are approaching each other. So let's say they collide, okay? Initial velocity chu u1 to u2 na chi. Collision zawa chu final velocity chu v1 to v2, okay? Atile hin here chu pita. We know that E, right? We know E. E is what? V2 minus V1 divided by U1 minus U2. Okay. Chilai para he V2 chu ping pot ha. So V2 equals to E into U1 minus U2. So plus V1. Yeah. Hichipa he na. Tu hin chila hin momentum conserve lechun. As I say chu piha. In all the three cases, momentum is conserved. Okay. Momentum conserve lechun. So here I will have P initial equals to P final. So initial so piha m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. It's pen here final v1 v2 so final velocities are u1 u2 so initial velocity na. Chila hi chila equation number 1 tu dekhat pa. Equation number 1 pa hai na. Hi v2 pa hi chila v2 ahin el leu chun pi pot ha. So here I will have m1 into u1 plus m2 into u2 so equals to m1 v1 plus m2 into ipidiha. So E into u1 minus u2 plus m2 into v1. Okay. To rearrangement tha bol na chala he iti bol ha. So you transfer everything masa bani v1 hold ta v1 na. V1 i holding wala chun chala v1 ma chala v1 na. So hi chipa hi veilanga transfer leu chun. So here I will have m1 u1 plus m2 u2, okay, minus m2e into u1 minus u2. So this is equals to m1 v1 plus m2 v2. Na chi he. Is a derivation of point mo beselo. So final formula po bose ko na by had na. Is only I want to show you how we derive that formula. Okay. So chilai ko na hi. So here bracket pa hong leo na chi bracket pa hi. So if you open this bracket, what will you have? I will have m1 u1 minus E into m2 into u1 plus m2 into u2 minus plus E into m2 into u2. So m1 plus m2 into v2 v1. Okay. So this is v1. Right. So here you have some like terms. Okay. So u2 to u2 chalai hom na si u1 to u1 so u2 to u2. Okay. So you take u1 common. So I will have m1 minus E into m2. Okay. u1 so plus m2 plus E into m2 into u2 is equals to m1 plus m2 into v1. Okay. To hin na m1 plus m2 hi vailanga transfer leo chun chepa he. So it will come in the denominator here. Okay. So I will have here m1 in minus E into m2. Na. So into u1 plus m2 plus E into m2 into u2. So divided by m1 plus m2. Chepen hi chepen hi v1. Nah, that's a formula. That's a formula here. So therefore, v1 is equals to what? So finally, I have m1 minus E into m2. Okay, divided by m1 plus m2. Chipen here u1 na plus m2 plus E into m2. So divided by m1 plus m2 into u2. Okay, it's a formula. See, this is a big formula. Okay. So you have to use this in every collision. Na question kitong lo si akom alang pia si final velocity yung kito alasun. So this is your formula. Okay. Chita bang aso na v2 zong chu bol leo chun chepa he na v1 pa he azo wa he la he. So here you can put it here. So here. Okay, v1 value. Bol leo chun v2 hung po de na. It's a final velocity chu piham. So here this is your final velocities. Okay. Suppose initially you have m1 m2 u1 u2 Aki collide ala chun ki collision so final velocity to v1 to v2 na chala hi. So here the formula will be, so final velocity will be given by, so as a derivation in ball pound so chipa hi. Okay, m1 minus e into m2 by m1 plus m2 u1 plus m2 plus e into m2 by m1 plus m2 into u2 like that. Okay, chipa hi v1, chipa hi v2. Right? Here's a formula pa hi na, so no need to worry about this formula. Okay. Alhang pi question hong kitu ala sun na. Perfectly elastic question ho CE equals to 1 perfectly elastic collision question ake dong ji na alhang pi acho. In general na for any types of collision formula final velocity hong kitu ala sun. So if you remember this formula you can answer that question. Okay. Ani na chun na. So alhang pi question kito ani perfectly elastic head-on collision a question kitong. So achi acho let's try to simplify that. Na azo equation na sila hi e equals to 1 put leo chun izanang pot diha. So here if I put 1 here I will have m1 minus m2, right? If I put here I will have 2 times of m2. Okay. Abanan sila hi e equals to 1 ka put alsun sila hi 2 into m1 hong pot na. Abanan sila hi ping pot diham so m1 minus m2. Okay. So now this is your formula. So this is very important. So v1 should be m1 minus m2 by m1 plus m2 into u1 plus 2 times of m2 by m1 plus m2. Yeah, 1, 1, 2. Okay. So here same thing. 2 into m2 by m1 plus m2. 2 into m1 by m1 plus m2. So sila pa hi sila nga hong long, sila pa hi sila nga long na ki cross din ito. So here you have to change the sign also. Okay, so this is your formula. Final velocity yung kito alasun na, so you have to use these formulas. So if the collision is perfectly elastic head-on collision, so the coefficient of restitution is 1. In this case, the final velocities will be given by these two formula. Okay. Aba na na si formula to special cases. Okay. Ni discuss utin. Tomom za ato na pensi ka bolo dio. I'm going to if you have time you guys just do research. Okay. First case to mass ang kiba na. See here, if the two masses are same, m1 equals to m2, abang collision so perfectly elastic a hiala chun. It's like formula hin m1 equals to m2 put chun ipinsan ang pot diha sila hin. So here, initial as u1 oma, final as u2 oma la chun. After collision, the velocities will get interchanged. Okay, so I will just try to verify that. Okay. So here, in this question, u1 to u2 so initial na, final v1 to v2 whole. So v1 is what? m1 minus m2, okay, divided by m1 plus m2. So into u1 plus 2 times of m2 into u2 divided by m1 plus m2. 2 in m1 equals to m2. Put leo chun ipyong pot deha chila hai. First term pa hai 0 ta chuse. So now this is 0. Okay. Right, so next is what? So v1 equals to, so 2 into m2 into u2, so divided by m1 plus m2, okay, so 2 into m. Okay, so there is no more m1, m2, so both are m. So what is this? So get cancel out, so now this is u2. Masa penso v1 equals to u2. Mass m1 pa final velocity chu na, m2 pa initial velocity chu hung nirita so. So that means the velocity is interchanging. Okay, similarly v2 whole leo chun. So v2 chu piha formula pa chu. So 2 into m1 into u1 divided by m1 plus m2. Okay, so minus m1 minus m2 divided by m1 plus m2 into u2. So lana chahiye. Ale m1 to m2 ke bala chun chipen hi 0 ta chu. So m1 minus m2 is 0, m minus m na. Chila hi bzan ho pode ha 2m into u1 divided by m1 plus m2 chu again 2m. Right, 2m to m gets cancelled out. v2 chu piha v2 chu u1. Okay. So now see the velocity gets interchanged. Okay, so this is the proof there. So just remember, perfectly elastic here mass so the velocity will get interchanged after collision. Okay, case number 1. Case number 2 so if both the masses stick together, question completely inelastic collision m1 to m2 chu initial velocity chu u1 to u2 hi chun after collision stick together total mass chu piha. So m1 plus m2 ta chula na jela hi. Okay, final stick together na so final velocity pa chu iting pod di ha. azo a big formula pa na batang inelastic collision jo piti na ha. So here what is the meaning of this? So this means E is equals to 0 na chila he. Formula lin pa chun equals to 0 put leo chun chila final velocity chung pot jo. So here we know that if they stick together na collision jo chu stick together la chun m1 to m2 chu velocity ki bang da cho v1 to v2 ki bang ni ti nai cho. Okay. Khat pen pela leo na cho m1 minus E into m2 into u1 divided by m1 plus m2 plus chilai pia m2 plus E into m2. Okay. So into u2 divided by m1 plus m2. Hichi chuna formula pa cho. Ale inelastic completely inelastic here chun E to 0 so chila in E0 put leo chun izan pot de ha. So here this term is 0, this term is 0. Okay. Ale m1 into u1 na. So plus denominator ke bang so chila he. m2 into u2 divided by m1 plus m2. So here final velocity cho. His line head has pen here. So what is this? This is basically the initial momentum. Okay. As you question ako na m1 kpj m2 kpj u1 u2 kpj jol hang pia ko. So in order to make calculations easier, his depends on hina direct atan jite. So initial momentum divided by m1 plus m2. Okay, in short, final velocity pa cho na. So here I have written p v cho piham p initial divided by m1 plus m2. pi cho piham initial momentum m1 u1 plus m2 u2. Okay. Right, then is special cases. Okay, there is one more special cases where first mass pa hai na, second mass pa sounds only so if mass m is much greater than m. Okay, so this one you do a little bit research and you just go and see it. Okay, book ho vela so now meto. So I will keep this one for you. Case ni chala ka discuss is ana chala hai. Okay, finally before doing questions, kinetic energy loss as I say pause na abang la question ako kitong si so collision to if it is not perfectly elastic, we know that energy loss de chula na je energy loss to itin calculate dio ha. So tang loss kiti to change din chula na. So how much is tang initial as suppose here collision masanga chu 100 joules so ale collision na hi 50 joules lose ala chun final chu bizanum de ha. So 50 chuna chela hi zala so somnga manala chun somngam nan chula ale question asu chipen ki hello tiu de. Okay, khutile energy loss ke dor chun itin hol dio ha. So here I have to subtract the final value from the initial value. Okay, chipa he ke initial here is ke final here chun energy loss pa cho pi ha. So what is the k loss? Kinetic energy loss. So final minus initial, right? Chu pi ham 50 minus 100. So here this is minus 50 joule. Ibola minus 50 ham tela minus kiti chun loss avel sa na cho. Okay. Right? Energy loss calculate dingal chun final to initial pa so subtract boil chun na. So you'll get the kinetic energy. Okay. Okay, abana question solve pan daw na. Theory bol so chan tan tin. So okay, problem 3. So in elastic collision, so here you're given 4 options. Okay, mas happen to piham the initial kinetic energy is equal to final kinetic energy. With an elastic collision as a PTOTA, energy kinetic energy ki conserve it. So if kinetic energy is conserved, so KE initial should be equals to KE final. Okay, answer to piham option A. Okay, abana chu question 4 in inelastic collision na. In elastic collision, so kinetic energy ki conserve lo cho. Energy loss na chila he kasi azo I say to bang wacho. So here option cho velo chun masapa he ki bang na option cho initial kinetic energy equals to final kinetic energy. So this is wrong. Okay, second na chu final kinetic energy is less than initial kinetic energy. To ache masang sana ka vel sa cho betang chila he energy loss hongo mala chun na initial chu 100 a hiala chun final chu energy loss ja chu kim su ta chuna chila he. So you can see that the final value is less than initial value. Okay, so answer to piham. So the final kinetic energy is less than initial kinetic energy. Chiban to piham tala inelastic collision na. Okay, next problem. A particle of mass m is moving with velocity v collides with a stationary particle of mass 2m. Hiti ahe na. Mass m chu chi heza speed to v ki pina chala he. So speed v mass m. Okay, khat chu mass 2m chipa hi rest saum na chi initial chu velocity is 0. So after collision they stick together. Okay, they stick together as a special cases ai pau chu na chala he. stick together also final velocity so mane ke bangta so chala hai. Okay, they continue to move together with velocity. With direct formula kapi chupita. So final velocity so p initial divided by m1 plus m2 tiu. So na chipen here. So if you apply this one, with initial momentum so ham chala hai. So initial momentum so m1 into u1 plus m2 into u2 so na here. So here m into v plus 2m into 0. Khatpa so raise am so initial acho. So that means what mv p initial so na chala here. Ale m1 plus m2 so that ha chala here. So therefore, final velocity equals to p initial to m into v divided by m plus 2m. Which is that ham m into v by 3m. So mm gets cancelled out. Final velocity is that ham v by 3. Okay. So answer is v by 3. Question is simple as I bold. Question hard ta ka koi lo chu chalai lecture hai. As you ham dele concept is so we are still learning the concept. Na. Just a question complex that solve sang chu nya chu cha ho level nim hoi solve fa chalai kuna chu he thei va jong chun phaso chala na. So here next question, problem number 6. Two bodies A and B of the same mass undergoes completely inelastic. But then completely inelastic it is ha. So they will stick together after collision na. Tang chala he A to B na chala he. Body A to V1 achia question aki pidana ko. While body B is at rest. Okay. Chipahi rest oma masapahi V1 achi na chihe. The velocity of the system after collision is V2. Batang collision also stick together also velocity chuke bang na ni ni hona cho. So here formula ka seba so V equals to P initial by M1 plus M2. Aki stick together ala na. Chila he P initial so that ham same mass ati cho. Mass so M to M lao ta chila he M to M atile m into v1 plus m into 0 initial momentum so na che. So pi value chu biham m into v1. Okay, chipa chu hela input leo chun v chu biham m into v1 divided by m plus m mass ke ba ja na chala he. So here I have m into v1 divided by 2 into m. So mm gets cancelled out. Dang he final pa chu biham v2 ke ti chuna che. So therefore this is v2. Okay, so we are finding out v2. So v2 equals to v1 by 2. Question chun pi do ham v1 is to v2. So here v2 pa kho zira transfer leo chun. So here 2 pa kho chung la zira 2 by 1 is equals to v1 by v2. Ratio to 2 is to 1 ahi ngai so chala hai. So you see this one. Answer to B. Na chepen hi medical exam question na. Okay, next problem. A block of mass 2 kg is moving with 2 meter per second, collides head-on with another block of the same mass. Masapen so mass ke bang na chala he object tene chu block tene so mass ke bang. Khatpa chu 2 meter per second na chintin khatpa chu rest saum na. So that means something like this. Block khat chu chala he 1 kg ma 2 kg zo na. 2 kg hiza ama hi 2 meter per second na chi zo. Khatpa chu same mass hiza so chi hi rest saum na chi. Question chu pm, what is the maximum kinetic energy loss? Maximum kinetic energy loss is the maximum de ha. What is the case? But collision type to me say uchula na. Type to masapena so perfectly elastic is a partially elastic is a banan so perfectly inelastic chula na. Deformation so vela chun hoi lai pen ki ha deform pena. So in which cases the deformation is maximum? But body ten is on stick together parts on deformation so maximum chula na. So here they are asking you for a perfectly inelastic collision. Okay. Question also ki mention lo wanga chuna. What is the maximum kinetic energy loss ati cho? Maximum kinetic energy loss iti phale ham tele perfectly inelastic phale na chila hi. So here that means the bodies will stick together after collision. Okay. Chipen hi zat ham 4 kg. Okay. Final velocity to that ha. Initial momentum chepiham. So what is the initial momentum here? M1 U1 plus M2 U2 na. M1 chepiham 2 kg, U1 chepiham 2 plus 2 into khatpa chu resa na 0. So here 2 are 4 plus 0. So that means P initial is what? 4. Okay. Formula to dungzu ya chu V chu zat ha. So P initial by M1 plus M2. Okay. Value put leo chun 4 divided by 2 plus 2. Chuchupi ha 4 by 4. So this is 1 meter per second. Okay. Finally, after collision, also velocity to be 1 meter per second. Okay. to chu wetang kinetic energy loss ati chula na zo ka sei banga chu loss pa chu tin hol di ha final kinetic energy minus initial kinetic energy yeah. So what is ke final khuisa idem so ke final so half into m khuisa ha chalai kho 4 chula na aki combine hona la chun 2 plus 2 to 4 is a final velocity khu 1 so 1 square half mv square that ham chu 2 joules okay. Initial kinetic energy so that ham ke initial equals to half into mass masapa khu 2 into 2 square plus khatpa khu 2 into half into 2 into 0 square na tang body chum heda chu individual kinetic energy na sum diu chu chalahi okay. To solve the ponam. So here I will have here 4 joules. Okay. Atile energy loss of him ke loss. So how much is this? Ke final minus ke initial. Okay. Value put 2 minus 4. So which is minus 2 joules. Okay. Kinetic energy loss part is at ham minus 2 joules. Okay. Abana, a block of mass m hits another block of mass capital M elastically. Okay, the transfer of energy is maximum. To hi tang energy loss hilo the energy transferred pa na. Tang he case pa hi it's tang energy loss lo wala chun tang hita hi example so I have a block mass m here. Okay. Chipa hi YouTube to che kharpa so resin ko yutena mass m pa he so res au maintain. So this is address. So energy pa hai na ta hidaya khapa hi half mu square jona japan half mu square heza so chipa hi hilai kuna transfer na dinga hai na the energy loss au malachun energy transfer pa chu see whatever energy is not lost is transferred. Okay, so this is the case when you have chelai derivation macha bol da ta chipen hi result he jo chipen hi jing ta. So here this is possible only when the two masses are equal. Okay, mass ke balsun velocity ki holding energy transfer pa na chipen maximum hindi cha chala hai. So let's not do any derivation or any proof like that. Okay, so simply remember energy transfer to maximum it's itipal om diham tele mass ang ke ba phalasun. So in that case the energy transferred is maximum. Okay, abana. So I think this is the last second question. Okay. A body of mass A of mass 4m moves with speed u, collides with another body B of mass 2m at rest. Body A chipahi 4 u wachi na chipahi mass 4m hiza khatpahi B to rest omna chi chipa mass is at ham mass 2m. The collision is head-on and elastic in nature. After collision, the fraction of energy lost by the colliding body. Initial chu pa in 100 joule anei cho chila hi ale collision a hi chin energy transfer na chi to chu batang hi chila hi mass ke ba lo ja chu energy transfer pa maximum hi lo cho chila hi jong la izat ki transfer ram 4m pa chu initial chu chin la chun suppose 100 joule anei la chun if it transfers say 40 joules a pi tiu da chila hi khudile energy a pa body a pa chun b a 40 joules a transfer la chun remaining chu da 60 joules chuna chila hi 60 joules remaining. So, energy a transfer pa chu see what is the fraction of energy lost by A? A pa and a transfer see it is the energy lost for A, right? Okay, it's a part of 40 divided by 100 into 100. So this is in percentage. His percentage is a fraction of the overall 100 pa hisa lo dina chipeni. Aji chu question na bang percentage sa ka dong betaw. Energy percentage of energy loss. So here they are loss divided by the original value into 100 percentage. Na fraction of the overall 40 by 100. So that means 2 by 5 is the fraction. Okay. The fraction holding us being initial kinetic energy. So the initial kinetic energy is required and final kinetic energy of this is required. Okay. The final velocity holong here. So here what is the value of v1? So a big formula pa so v1 so piham so m1 minus m2 okay into u1 divided by m1 plus m2, right? So here plus 2 times of m2 into u2 divided by m1 plus m2. Okay, value pulachun 4m minus 2m to 2m na into u divided by 4m plus 2m to 6m. Okay, plus 0. aji chu u2 chu 0 so chi so u2 is 0 therefore the whole term is 0 let's see zarang pot dia chala he so here if you solve you'll have what so 3 right so here you have u by 3 okay to chu kharpa final speed hol ngai no pucho okay without doing solving that also you can find aji chu to hi ke initial hi zat ha hi che pen hi focus deu chu aji question jon e pa do chala na chala hi so ke initial chu pi ha so half into 4m into u squared okay chi zat ha so this is 2m u squared okay ale finally also speed ki heta chala na chi so what is the final kinetic energy so half into 4m into u by 3 whole square na chi solve la chun zan podem 2 2 are 4 so 2m into u squared divided by 9 okay 3 are 9 na ale final to initial aki heta chun energy loss ki heta cho e pa bo se hen na e pa hen energy el zat loss ham chi chu ki solve theta cho so here what is the energy loss by a so delta ke e divta che so which is final minus initial so 2m u squared divided by 9 minus 2m u squared okay in this case bata chi hi initial minus final kan bol so chala hi aji so biam tele a value pa pa se de so energy loss pa so na if you so you can also do it like this you get negative value but don't worry okay we are solving fraction here na atila chobatang 100 joules o mana chelai kuna hi 40 joules api do alason remaining to 60 chulana to hi 60 pa hi tang final heza chepa hi initial so initial apa la final pa so minus bol chun hi chepa hing pot cho e hon hi chepa hi hol no mo cho je so here how much 2 into mu squared minus 2mu squared divided by 9 is that hong pot di ha so 9 2 are 18 so 16 into mu squared divided by 9 okay to chu ratio do chula na ratio chu so the change with respect to the original okay so this one so fraction chu bi ha so ke divided by so ke initial chu bi ham so 16 mu squared divided by 9 so divided by 2mu squared okay just solve la chun san pot diam so mu squared 2 1 is 2 2 8 okay a fraction ado chuna question chun fraction ado chu fraction chu pi ha so fraction is 8 by 9 okay to cha fraction hi lo percentage ong kitong thai cho percentage ado wala chun chipen hi so this one so 8 into 9 multiply 100 chi bol sing le chun okay percentage as ha so this is what 800 divided by 9 na so 9 8 are 72 80 9 8 are 72 80 so around 88% energy loss pass na so this is 88% of the energy is lost okay okay last question question here statement question na chela hi statement ni kipia chito dungsu ya chu adi lo na chela hi so 4 options are given okay must happen to the 3 identical spheres of the same mass okay same mass ati le chun so here this is m this is m this is m okay same masses undergoes one dimensional collision to head on collision na figure with initial velocities of 5 2 to 4 kp na a figure ka so pa hi 5 2 and 4 is given if we wait sufficiently long for all the elastic collision to happen va so final velocity chepeni so this will be the final velocity edicho okay let's check it batang chila velocity chepen hard pen chola na je he chepen hi slow he chepen hi fast cho initial chun velocity he chepa hi ada thar da cho okay so that means this 5 will collide with this first same mass here perfectly elastic here chun velocity ki suki interchange de chu ise chola na chila he ale first collision chu velocity so first collision achu massa pa to second na pa hi abc diuta a b c a to b ki collide la chun velocity ki exchange da chu ale first pa chu to hi 2 meter per second achi ding second pa chu 5 meter per second achi da chu lai okay ale second na pa chu 5 achi ala chun third na pa chu 4 achi chula na chela hi so 5 is greater than 4 to chu second na pa hin hi che pa hi collide ki de na so it will collide on the third body also aki collide ki no ala chun finally what will be the final velocity ki interchange ke hunne cho chala ya 5 pa 4 pa jong hena ki interchange ke hunne din final velocity chu hi je pa 4 pa 5 meter per second hung din second na pa chu 4 meter per second hung din cha. Okay, so these are the final velocities. dm so vh 4 vh 2 hi ngai na, so therefore the first is wrong. Okay, assertion is incorrect. Ani na pa jo biham, so in a elastic collision between identical masses, two objects exchange their velocities. Di na so I say pa jo, so here the reason is correct. Okay, assertion is incorrect but the reason is correct, B. Okay, so that much na collision a chu theory apai mo se si bola ta so jela here. So after this one, so whatever book you are following, right, so fingertips tata elole dc pandai hoi tata achiever mai tata na, so whatever coaching materials you follow, so now you can go and solve them. Okay, so we have done all the basics part. So practice ngai chu chelai question is solve for say, so this is not enough. Okay, you have to follow one book and then you have to solve question from that book also, right? Okay, so I hope you understand. Formula ho he cho he na, so try to remember these formulas. Okay, so hi chan ju tan din na, so if you enjoy the classes, okay, if you temkhat bena phat chum bi wa jong na, you can share among your friends. Okay, those who are preparing for JEE ho medical exam tata engineering exam tata loi ho ki, see those who are preparing, you can just share them. Okay, right, we'll stop this lecture here. Kina para ho rotational motion I do that. So this much, thank you for watching.